R&D in solar thermal will continue in this country. And also R&D and carbon capture and sequestration will continue, but we will do it with lot of care. We will not go just for carbon capture and sequestration all our thermal power plant, but we'll take on very calculated manner. We'll move. That is another thing. Then we told the whole world that there should be some carbon space for every developing country. Well, we can't leave coal. Coal is going to stay remain our mainstay even another 20 years. Let me tell you very frankly. Whatever we may do in the renewable energy sector, but coal is going to stay remain our mainstay. The countries between Tropic of Cancer and Tropic of Capricorn, where there is this high DNI, they should join and form a international solar alliance, and that is a reality today. Our Honorable Prime Minister, who is going to US today, who is in USA, he will also focus on what the activities of the International Solar Alliance and what way we are contributing in the solar thermal and solar energy. 2 degree centigrade target may be achieved or may not be achieved. I don't know. I cannot comment on that, because the whole world emission today, let me tell you, is of the order of 40,000 million tons of CO2. That is 10 gigatons of carbon. 10 gigaton means 10,000 million tons. Giga means 1,000 million. So 10,000 million tons of carbon, that multiplied by 44 by 12 becomes about 40,000. So much million tons of CO2 is being emitted, and our total emission of whole India is of the order of 2,400 million tons per annum as on date. That I'm giving you a figure of last month, that is August. Or it was on 14th August. Let me tell you very clearly, it was 2,400 million tons per annum. And out of this 2,400 million tons per annum, remember, my friends, that we are our contribution because of coal-fired power plant is of the order of 1,200, about 50%. 50% of the emission of CO2 is coming from our coal power plants. So we have some means to say, we have some methods, and there are only 5 methods. Just like God has given us 5 fingers, there are 5 methods. Use of energy conservation and energy efficiency improvement. That is first method. Second method is use of nuclear and hydro, more and more application of nuclear hydro. Third is use of renewable energy and biofuels and biodiesels. And fourth is use of fossil fuel based clean coal technologies like supercritical technology. We are in the era of supercritical today. All our thermal power plants now being commissioned are mostly in the power sector by NTPC and all other state electricity boards. They are all supercritical. That is thing. Then and there is a fifth dimension, just like our thumb. There is a fifth dimension which is very, very, very important. Thumb is most important. You know the story of Eklavya. Thumb is most important. The thumb is the carbon capture and sequestration, directly capturing the CO2, directly capturing the carbon dioxide from the chimney. That is carbon capture and sequestration, CO2. Let me share the PPT now and start my. This was only introduction I was giving you. Okay, are you able to?
Yes, sir. Your slides are visible, sir.
The slide is visible.
Yes, sir. It is visible.
Let me change the slide also, and the change is also there. Yes. Okay. Today I'm going to talk on solar thermal integrated carbon capture and sequestration plants. There are a number of plants in the whole world based on carbon capture and sequestration. Many of them using monothermal amines technology, some of them using some zeolites and all that. But solar thermal integrated carbon capture plants are only 3 in the country, in the world. First one is in Alabama, USA. Second in Australia, and the third one is we have got jointly with RGPV where Professor Sunil Gupta, the Vice Chancellor of Rajiv Gandhi Technical University, is our co-PI. Dr. Savita Vyas was also one of the co-PI in this project, and I'm going to talk about this particular project, the Solar Thermal Integrated Carbon Capture and Sequestration. When we deploy carbon capture and sequestration plants on any chimney of a power plant or any thermal power plant, there are several challenges that must be overcome. And biggest challenge is sensitizing the power sector utilities. Power sector utilities don't want to do it. Ministry of Power, particularly and the Ministry of Environment, Forest, they are all committed to do it. But power plant authorities are still not in a position to do it. They say once we do this, there will be 30% reduction energy penalty. Why this energy penalty is coming? Because CO2 is captured by monoethanolamine, and you capture the CO2 in monoethanolamine, then you have to release it also, and you can release it by heating at more than 125 degrees centigrade. And for releasing this, you need steam. And if you take the steam from the boiler, what will happen to the power? Power will reduce. Your cost of power will increase. So reduction cannot be allowed more than 4 to 5% or 6%, let me say, and that is not possible by taking steam from the boiler. If you take steam from the boiler, minimum penalty will be 13%, 15%, 20%. It's a very high penalty, and this penalty will increase cost of generation of a thermal power plant. So this pilot plant was sanctioned by Ministry of Power, CPRI, with that target only in mind. That was the target in the mind at the time. CPRI, when they gave it to RKDF and RGPV jointly, because RGPV already did some of the work. Pilot plant was erected in the year 2005, and it was working till 2012. It was working there. The broadly, this is a plant which captures about 6 tons per day of flue gases, 50 kg per hour approximately. CO2 source is a flue gas from a boiler, coal-fired boiler has been installed. I'll show you a photograph of that. Solvent is monoethanolamine. SOx and NOx removal is by sodium bicarbonate and sodium hydroxide. Scrubber units. Solar thermal plant is there for supplying steam. The solar thermal plant is there for supplying steam. There is a algal bioreactor and a tabletop hydrogen plant, which has been given by RGPV from the old project. This plant is installed at RKDF University at the J.C. Bose Interdisciplinary Research Park in 2 acres area. Let me show you this was a carbon capture plant at RGPV, which was made in the year 2005 and 2006, with the help of Department of Science and Technology, DST. This was a DST project. I was the PI of that time and director RGPV and that time. Now this is the plant which has been now commissioned actually at RKDF University, 50 kg per hour plant. If you see this plant in the bottom, you will see solar integrated carbon capture plant. There are solar panels, solar thermal panels, steam producing solar thermal panels are there, which supply steam. On the right hand side in the bottom, you can see a boiler, coal-fired boiler, the steam and flue gas generator. This generates steam as well as when the sun is less, at that time it gives you steam also. Otherwise, the steam is taken from the solar plant. I'll go back again to this. Why this? What is new in this plant is use of high density halide salt in solar thermal unit. Well, sun is available only for 5 hours at a proper DNI, particularly for the solar thermal power. But for rest of the hours, 10 to 15 hours, is a salt which is called halide salt. This halide salt has been brought from USA under a collaboration with the USA. RPI, Rensselaer Polytechnic Institute. RPI is a very old university of about 198 years old university in New York. Even the Brooklyn Bridge was made by the RPI at that time, some 195 years ago. Well, so this is a very old university, and they are collaborating with us. And Dr. Partha Datta is co-PI in this particular project. One of the co-PIs, co-PI advisor, co-PI from US. An optimized design of reactors is very important. Steam requirement is met by 8 parabolic discs. Parabolic discs are there, reflectors, 5 kg per hour capacity, and having 16 hours of thermal storage of halide salt supplied by RPI USA. Additionally, two shufflers have been installed for meeting the steam requirement in case of lower solar flux, particularly in cloudy days. This year, the cloudy days have extended to 4 months, almost 4 months. Right from 15 June onwards, there is no sunshine in Bhopal. Just yesterday, maybe something has started, but that's not sufficient. So we have to use additional solar panels. This plant was tested from January to June this year. January to June this year, this was tested. In between, there was a lot of COVID period and all that, so testing has got delayed, which was supposed to be 40 days testing. It has extended to so many months because of the COVID. The pilot plant, you can see the pilot plant testing. You can see the chimney where the is there. The steam is coming from the solar panels from a pipe. On the left-hand side, you can see pipes steam, supplying steam. You can see number of towers. There are 3 towers. The white tower is a stainless steel tower of monothonolamine, and the blue towers or gray towers are sodium bicarbonate. And on the left-hand side, there is a reactor where the steam is supplied both from the boiler as well as from the solar panel for releasing the process like this actually. When the flue gases going to the chimney are diverted to this scrubber units of gray scrubber units, they capture SOx, NOx, and ammonia, and that clean gas comes to the MES tower. That is the central one, the stainless steel tower where MES solvent is there that captures it. Once it is fully captured, becomes saturated, we transfer to the middle one, stainless steel tower. From there, we send to the reactor tower, which is exactly on the left-hand side, extreme left in this particular photograph, where the steam is coming both from the solar as well as from the boiler. We are supposed to take from solar and reduce as much as possible from the boiler to reduce the energy penalty. So energy penalty at the moment is about 4 megajoules per kg of CO2. That has been reduced to about 2.8 by use of this solar steam. That's the main thing actually. What investigations have been carried out? The installation of solar integrated carbon capture plant of capacity 45 kg per hour of CO2, about for 50 kg per hour CO2, which is taken from 250 kg per hour flue gases from the associated coal-fired boiler. About 18% flue gases, the CO2 is there in flue gases of the coal. Feasibility study has been done for a 500 megawatt unit also. But ultimately, this is not the end. This is only a beginning. We are targeting at a 500 megawatt machine, and the plant which has been chosen is the Anpara B power station, unit number 4, at 500 megawatt machine. This is in Singrauli region of Madhya Pradesh. Actually, it is coming under UP because UP and MP, the border is there. It is managed by UP State Electricity Board, and control is from Lucknow. But this is in the Singrauli region of Madhya Pradesh. The feasibility study has examined various options. One is captured CO2 depleted. What will happen to CO2 actually? As far as pilot study is concerned, in the bottom you can see the pilot study. Either you can produce hydrogen or you can produce algae. You can produce biodiesel through algae route. Biodiesel is produced generally by a jatropha, but algae route is also one of them. Algae route can be followed. Hydrogen production is also possible. These are pilot studies, but on a large scale, when you go for a 500 megawatt machine, you have only 3 options, or rather 2 options at the moment. One is captured CO2 depleted coal mines. Kakri coal mine has been selected in the northern coal fields we have selected and captured CO2 for enhanced oil recovery. And this is possible where there is a oil well nearby. If there is no oil well nearby, this option doesn't work. Then the third option also, basalt rocks. There are some areas in Rajasthan where lot of basalt rocks are available, and once you inject this CO2 in the basalt rocks, it converts into calcium carbonates, and that stays long, millions of years. Calcium carbonate can stay. Some countries are doing carbon capture by bottling carbon CO2 and dumping into the sea, but that's not correct. Dumping into the sea is not the answer. It affects the marine life. So, as far as India is concerned, as far as Ministry of Power is concerned, they say if a power plant is near a depleted coal mine, feed into the mine. If you feed CO2 into the mine, the methane increases. And that is the biggest advantage of depleted coal mine. Most of the coal mines, my dear friends, these days, they are open cast mines. In Singrauli region, there are 22 open cast mines, Khadia, Kakri, Dudhichua, and number of them. And depleted coal mines are also three. Three mines have completely finished by NTPC. There are big projects of NTPC, Shaktinagar Thermal Power Station, Rehand Thermal Power Station, Vindhyachal Thermal Power Station, and Anpara. These are 4 mega projects actually and producing about 15,000 megawatts power generation from these projects actually, and total in the Singrauli region is about 22,000 megawatt, which is a very large cluster. Such clusters are there not only in Singrauli, it is there in the Ramagundam. Ramagundam also, their big project is there. NTPC project is there. Then some new projects also coming up by various other private players in Ramagundam area. Also, Farakka, Korba. These are there are a lot of open cast mines, as many of them had depleted. So, but that could be one of the options. If you look at the requirement of water, about 70 kg per hour required for this carbon capture plant of 50 kg per hour, requiring steam generation 40 kg per hour minimum. Water gas shift reaction gives 18, so total about 70 kg per hour required. Auxiliary power consumption also increases to about 100 kilowatt. Pumps and boilers, solar trackers, because solar panels have to be tracked with the sun. The 2-axis tracking is there. So about 30 kilowatt is the power consumption for that. Analysis of trial run says that carbon CO2 capture capacity has increased to 87 to 90%. We achieved at about 82% in RGPV at that time. CO2 released from the reactor is of the order of 18 to 23% of CO2 is released from the reactor. And energy penalty has come down to from a level of 4.2 megajoules per ton of CO2 to approximately 2.18 megajoules per ton of CO2. Reactor requires start releasing at 115 degrees centigrade, but we supply steam of the order of 159 degrees centigrade. And maximum inlet temperature, the boiler shuffler is 169 degrees centigrade. Trial run has been done. Well, all these things are there. I'll talk about scaling up. Actually, scaling up big issues. If you talk of 500 megawatt unit, it emits about 8,000 tons of CO2 per day. 330 tons per hour of CO2 is emitted from a 500 megawatt machine. And 330 tons per hour multiplied by 44 by 12, so much of yes. Well, that's so much carbon emission is there for 12 by 44. If you do, then that will be carbon. But if you scale up, there are biggest issue will be what you will do with that carbon dioxide. If you produce algae, it will be 55 tons per hour algae actually, big algae, big quantity of algae. How to manage that algae, Chlora vulgaris and all that. So all those things are discussed further. Strategy in scaling up is there. How much we should capture? Shall we capture 30%, 40%, 50%, or 100%? Algae plant is from which stage? What type of algae? what algae can which can be produced in ash pond, because the open area in a power plant is a ash pond. In ash pond, if algae can grow, Acro vulgaris or Raphidium, these are two varieties which can grow in ash. And there is one PhD recently from RGPV by Mr. Soni. He did from algae. He used algae for production of biodiesel. Well, algae, we are also producing a biodiesel. I'll show you the particular photograph of that. Anpara Singroli to go for a this one, and we were given this place that the from ID fan, induced draft fan of the boiler to the chimney. This is a duct, and from this duct we have to tap out the flue gases, and and this is the layout plan of 50% carbon capture plant. Then we also tried at Koradi thermal power station, 660 megawatt. We said let's go for Koradi, because Koradi there is a CPRI's base is also there, Central Power Research Institute. On the instance of CPRI, we went there. We found out different location. We found there is a lot of space available, and from this duct, where you can see the duct opening of the duct, we tapped out the flue gases and did some tests. By integrating into the of carbon dioxide, integrating CO2 capture to thermal power plant is a very big issue. Lot of problems are there. And in Anpara B, Anpara, where we wanted to make it, it came out about 70 or 75 by 125 meter. That is the size of plant. And this is a plant designed by Toshiba, because Toshiba is supplier of this particular 500 megawatt machine. They did some jointly with us. They did some feasibility study, and they made the designs of this particular plant, CCS plant in Anpara. This is only proposed one. This will come up maybe in 2025 or something, but we have to continue a lot of trials to reduce the energy penalty on these on this plant, as well as we have to revive the RGPV plant also, because the RGPV plant has got some distinct advantages of flexibility as compared to this particular RPDF plant. Actually, requirement was told to the project authorities that we want your polarized fuel power plant. We want CO2 capture capacity 6 tons per day, 2-shift generation, small plant. Let's install a small power plant, a shadow-free area of 15 to 25 square meter for installation of solar disk. And we explained to the project authority that a selected power plant will be the first carbon neutral plant having CCS integration in India. So that is the advantage you are going to have once you go for a carbon capture plant. Get enriched business of green fuel by producing methane, by producing cryogenic fuel, by producing biodiesels. That is there. Solar integration will boost or reduce the energy harness. Well, if solar thermal integration is something which is being thought for coal substitution also. Thermal power plants, the old thermal power plants have got a lot of space. They occupied lot of area at that time when these plants were made maybe Hardogan power station, or maybe the power station Chandrapur power station, or maybe Koradi old power stations. They had lot of area where lot of solar plant, Scheffler disk can be made. And the advantage of this is wherever you require low temperature steam, why use coal? You can reduce coal consumption by about 10% if you integrate solar. So solar thermal can be integrated, but the place, I mean, the high solar flux, high DNI is required. Solar thermal storage can help us by it halide salt. Halide salt, if you use for thermal storage, it will heat up. The advantage of halide salt is once you heat to 700 degrees centigrade, it remains at cools down to 300 degrees centigrade in 16 hours. It takes 16 hours to cool down from 700 degrees centigrade to 300 degrees centigrade. That is the advantage of halide salt. And that is the temperature at which steam can be produced. So why not use, you have solar thermal integration. And if you have solar thermal integration with energy storage, we have a project here at RKD. Those of you who are interested, they can come and see. This is the Ministry of New and Renewable Energy big project on solar thermal storage by jointly with USA. The equipment has come from USA and supplied by RPI USA. Then power station authorities were raising a lot of queries. They say that while the project authorities were positive about the installation of proposed plant at Koradi, Grasim Industry in Nagda also we tried. Because Grasim is a small plant, it is in Madhya Pradesh near to Bhopal, so much easy to install a pilot plant there. They expressed desire to examine the result of trial, but they say that we want to examine the results of the plant, which is jointly commissioned by RGPV and RKDF at RKDF campus. We want to see the results and see the energy penalty. So those results are being shared to them. Power plant authorities also desire to have a formal letter from Ministry of Power for installation of this pilot plant. They say, let Ministry of Power write to us, and they want a tripartite MOU also, as suggested by project authority. They appreciated the initiatives, but they say that yes, it is for abatement of climate change. We approached NALCO also. NALCO is a plant where flue gas is directly going into the algae pond. This is very surprising. The flue gas, not CO2. The flue gas is directly entering into the algae pond, and algae is growing with that. And they are producing biodiesel there in NALCO. So this NALCO plant, but there is no further response with them because they may not be interested. The queries from power plant were replied, and they were told that initial installation will require shutdown of only one ID fan. Shutdown will want to be issued. Number of days will need to install CSV plant will be about 30 days. Pilot plant can be installed at site only after testing. But they say all of them said that power plant can be installed at site only after testing at university site. Hence, coal-fired boiler is needed. That's why we had to install a coal-fired boiler. Otherwise, this pilot plant we wanted to install it one of the small thermal power plants. We tried at Mandideep. Some of the boilers are there. They also didn't agree. Then Grasim Industries, which was near, but ultimately Anpara was selected as I think it was a letter of the MOU has been signed, and hopefully this project will see its life. Input required. You will be surprised to see how much input will be required when we go for a 500 megawatt machine. The land area required is between a stack area now being used for desulfurization plants, fuel oil corridor, 70 meter by 125 meter or 75 meter by 125 meter, level 2 tire. Additional water requirement is 4 to 5 tons per hour. Additional power requirement is 4 megawatt. Remember, the auxiliary power consumption will increase by about 0.8%. Sequestration to depleted coal mines. Feasibility studies of sequestration indicates that estimated CO2 potential in India is India's estimated CO2 potential, where the CO2 can be dumped for years to come, for millions of years to come, is deep saline reservoir aquifers and reservoirs onshore and offshore. About 360 gigatons of CO2 can be dumped there. Depleted oil and gas fields, about 7 gigatons of CO2. Unminable coal seams, the coal plants which are unminable or the unminable or the depleted coal mines, we call them. Volcanic rocks, there are some areas where volcanic rocks are there. There are 200 gigatons of can be stored there. As far as NCL Singrauli is concerned, the estimate given by Ministry of Environment and Forest to us is 1.16 gigatons of CO2. That's very big. Even 1.16 gigatons of CO2 can be stored for years to come. Great. So sequestration, our feasibility study shows that 500 megawatt unit number 4 Anpara, EPC by Toshiba. Toshiba is the MOU has been signed jointly with UP Electricity Board. Its name is Uttar Pradesh Rajya Vidyut Utpadan Nigam. Its name is in Hindi now. UPSCB. EPC by Toshiba Corporation, and they said the best will be initially use Kakri coalfield for sequestration. Next, use Bina coalfield. Bina coalfield is much bigger in Singrauli. Those who have gone to Singrauli, they must have maybe knowing, they must be very familiar. Big power, big railway station also. The pipeline cost will be minimum via Anpara Shaktinagar highway road side. The old wharf wall of Kakri mine shall be used for the CO2 pumping station. There is a wharf wall mine. There was a wharf wall or a place or an area where coal was being stored for particularly for the monsoon period when the coal mining reduces. The coal mine output reduces by more than 40% to 60% depending upon the rain. So at that time, the wharf wall is used for feeding to the various power plants in the Singrauli region, maybe in Anpara, Vindhyachal, Shaktinagar, Rehand, any of the power stations, NTPC and others. Pilot study we did. Then we thought, let us concentrate on pilot study as far as this pilot plant is concerned. Why to dump this CO2 once captured into atmosphere? Let's use it for production of algae. So we tried with algae. This I'm not able to spell its name. Is a very complicated name. Some I believe US dry mass of algae. Before CO2 release, if it is 5.24 grams, it increases to 14. So about 2.4 to 2.7 times increase is there. Production of hydrogen we tried at RGPV also in the year 2009, and same technology is being used. And the plant which was lying idle at RGPV has been shifted here at RGPV for this testing purpose. On loan basis, it will be returned once testing is over. So we are able to produce hydrogen of the order of about 17 to 21% by volume. By weight is less. The study conducted on CO2 capture from flue gases and release has revalidated amine process. Basically, this plant has revalidated the amine process of CO2 absorption and conversion into multi-purpose fuels. Here you can see at RKDF University, you can see the CO2 being injected. You can see in the background, you can see the carbon capture plant. And here you see the algae pond where the algae is growing. Algae is growing, and algae growth is of the order of 2.5 to 2.6% times actually in 30 hours of CO2 injection. And CO2 is being injected to this particular pond. On the right hand side, you can see a SCADA system. This is SCADA, or the data acquisition system. It is a supervisory control and data acquisition system which is there. This system controls both the solar plant as well as the carbon capture plant, which you see in the left hand side. In the background, the chimney and all that carbon capture plant you are able to see, which is installed at the university. They're most welcome to see both these facilities here. Both of them are quite unique. As far as hydrogen production plant is concerned, this was brought from RGPV. You can see in the bottom, you can see this hydrogen production plant with fireball in the gasifier. The process is very simple. What we do, hydrogen is produced. What we do, we take lignite briquettes, puts oxygen, put CO2 into that, and the CO2 by burning of lignite converts into CO, and steam is coming from the boiler. You can see the steam coming from the boiler. This pipeline, the pipeline coming here. So the steam when combines with CO, it takes the equation of CO plus H2O is equal to CO2 plus H2. So CO2 plus H2 is produced. Then there's a small capture plant of NEA solvent where CO2 is absorbed and pure hydrogen is there. Right now we are burning this hydrogen, but in future some applications can definitely be found out, maybe fuel cell or whatever. Some people can work on this research. Actually, it's an interdisciplinary research. People can from the biotechnology department can work. People from various other disciplines, electrical, mechanical, of course, can work on these projects. The feasibility study, the input needed, which was told to power plant people was, again repeating it, about 70 meter by 125 meter with reactors at 2 levels. This will not be a reactor like the one which we have seen just now. That is like this, not like a tower type reactor, but two-stage reactor with additional water requirement for 4 to 5 tons and additional power requirement of 4 megawatts. Scaling up, this I think is not repeated. Strategy. Oh, sorry. This is a diagram gives the strategy, what should be done. Here you can see a boiler, you can see a turbine and a generator connected to the turbine. You see the carbon capture plant. The very first thing is what you will do with CO. One is CO converter. One option is convert CO2 into CO, and that CO can be used in the boiler using short flame burners. Normally the coal burners are long flame burners now. Tangential burners are being used. Those who are on the mechanical side, they know this long flame burners are used. The CO is the short flame burners. Then hydrogen converter is there. Hydrogen converters are there. Then that is conversion, which I was told. Algae plant. So implementation strategy is very important. The algae plant should be from the beginning or it should be after some few years. That is one thing. First is full bypass of CO2 and then recycling, or partial bypass. This is another point of strategy. You can see the plant engineers, the blue one shows the plant engineers construction and modification will be required in the turbine, because the steam will be taken from turbine, from the extraction of the turbine for regeneration to the solvent if there is no solar. But once solar is there, definitely this will be reduced. RKDF and RGPV specify the requirement, industry partners, construction and modification. So I hope you are able to. Are you able to see this diagram clearly, sir? Hello?
Yes, sir. Yes, sir. Yes, sir. We are able to see the diagram, sir.
Okay, right. Because this diagram is very important because it shows the feasibility study, how the feasibility study is to be done, and how the funding will come. From where the funding will come, that's another point actually. This demonstration projects, since the signing is done jointly with RKDF, RGPV, Anpara, and Toshiba, is a tripartite agreement actually. So the funding has to come from Japan, from the METI, Agency of Natural Resources Energy Conservation. Toshiba will also equipment supplier, demo plant, and Anpara TPS, power utilities, BHEL also has to be involved because many of the auxiliaries are from BHEL. Well, that strategy is under very initial stage because it is going to take a lot of time, many years to come before we go for a full-scale plant on a 500 megawatt machine. Again, repeat it. Here you can see the Singrauli region. You can see is a very highly polluted area. Singrauli. Average ppm level in Singrauli is of the order of 400 to 495. 400 to 495 is the figure given by Ministry of Environment for us. See the moef.nic.in. If you go and put Singrauli, what is the ppm level? Even in the daytime, like today, even in the shunt time, it will not be less than 400 ppm. So because large number of power plants are there around it, actually 20,000, 22,000 megawatt at one point in a small area. But it's a very ideal place. Rehend reservoir on one side and large number of coal mines actually. Big coal mines are 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 mines are very big. And Kakri mine, you can see the Anpara power station and Kakri mine. That's a route where we will take the pipeline. From Anpara, CO2 will dump into the Kakri mine, which is Kakri mine is a depleted coal mine actually. This is the route which has been given to us by ministry, and still working actually on this project. Actually, the many years to come to this to work this project. I don't know whether we will be able to do it or not actually, but maybe by the time I will be more than 76 years old when I affiliated colleges, they can work on these mega projects. They are interdisciplinary. People from biotechnology can work on various things. People from energy, from electrical, from mechanical, and even civil engineers. Big challenge for civil engineers also. Dumping the CO2 into the mine is a very big challenge actually, and dumping at the seam where you you feel that there will be increase in methane, because ultimate aim is increase in methane. Actually, methane has to be increased. So uh, this is well, my PPT is over because I wanted more time for discussions actually. RKDF and RGPV universities are committed to use renewable energy technology to deployment of solar PV plants. We have solar PV plants both. We also have about 500 megawatt here, 500 kilowatt PV. PV is one thing. I like PV somehow, but the future is there in solar thermal also. Remember, the future is there in solar thermal. PV is going well. PV is a much simpler technology, but solar thermal is a complicated technology. On left hand side, you can see Dr. Partha Datta from USA. He is testing the halide salt. The halide salt is tested by using a lens. You can see a 2-meter diameter lens. Okay, on the left hand side top, you can see a big lens, 2-meter diameter lens, with which the halide salt is heated to about 1400 degrees centigrade. And once we heat it to 700 degrees centigrade, I told you it is able to produce steam for another 16 hours, because sun will give you steam only for 5 to 6 hours. Solar thermal integration is very, very important. Deployment of solar PV plants, innovative R&D project, solar thermal in collaboration with RPI USA. RPI is working very hard. They had some big problems these days in COVID period, particularly that area were high COVID period. So there were a lot of setbacks in this particular. Otherwise, we could have started this project at Singoli at a much faster pace. So this is what I wanted to tell you actually at the moment. I must tell you the CSP plant condition in India is not very good. The concentrated solar plant today are total installed capacity is of the order of 25 megawatts only. Hello, am I visible?
Yeah. Yes, sir. We are listening, sir.
So CSP plants in India, if you think the concentrated solar plants, the technologies which have come up are based mostly on molten salt. Molten salt technologies are suffering from many of the issues. So the solid-based technology projects are only 3 in the whole country, and the first one is from Mount Abu, 1 megawatt plant where 700 Scheffler's units are there. This is Brahma Kumari Ashram, where the food is being produced by using solar thermal, and also there is a power generation of 1 megawatt. But the storage is a 3-ton. 3-ton. I wish I could have brought the photograph of that one. It is 700 numbers of 3-ton cast iron shells. They store the energy. They store the heat, and whole night when there is no sun, this produces steam, and this gives you steam round the clock there almost. So 6 hours in a daytime and 16 hours, 12 to 15 hours in the night time. So almost 20 hours, 18 to 20 hours, it is able to give the steam constantly to thermal storage. Second thermal storage plant which we envisaged was at RGPV. It is called CLCSP technology. Once you are at RGPV, you must visit this particular plant. Cross linear, Dr. Pandey is a PI at that. At one time, I used to be PI and I brought this project for the RGPV at that time. Jointly with Professor Tamura, who is the designer of this particular project. They are halostats actually, and these halostats focus and produce air, hot air. Hot air produces steam, and the steam can be used for various applications. But here also there was one more step which was going to be there, and that was this solid thermal storage. And solid thermal storage chosen at that time was rocks or pebbles. Pebbles and rocks were chosen as the thermal storage at that time. The installed capacity of India's contribution as CSP is less than 500 megawatt. It's a matter of great concern. While the world is having 25 gigawatt, 25.21 gigawatt to be more exact, installed capacity of solar plants. But a state of art says that we should go for molten salt as soon as possible for the areas like Jaisalmer, Bikaner, and maybe Pokhran area. Yes, good sites. Abhijit solar plant is coming up. Dadri, this Devakar is coming up. Gujarat Solar is coming up. KVK is coming up there. Well, so molten salt is also there, a technology which should continue at least for next 5-year plan. Next 5-year plan, I think the molten salt should continue, but later on we have to go for a much better technologies like halide salt technology or thermal storage technology or a technology where use solid materials actually.
Sir, are you showing some slides or are there no slides?
No, only discussing. Slides are there. I can share, but I have to search out from somewhere. Anyway, but in the meantime, I want a open forum for at least 15-20 minutes.
Yes. Definitely, participants. I hope it has been a respite because last 3 days we have been listening power electronics and converters and inverters and choppers. So, considering the multidisciplinary aspect of this course, today's lecture of this semester's lecture must have been covered the areas to other streams like you can say mechanical domain, chemical domain, and other biotechnology domain. So, queries are welcome. Participants, you may ask queries to Sethi sir because he's having a rich experience of project management and execution.
Yes, please.
Any candidates of other discipline like science, chemistry, mechanical, biotechnology, or electrical, mechanical, they wish to ask.
And those who are interested in the figures of cost figures, for them, I must tell you that today the power plant cost is of the order of 4.2 crore per megawatt. Per megawatt, thermal power plant cost is 4.2. And once you have this carbon capture plant, the minimum cost which is coming is 4.2 times 1.15, 15%. 15% is the increase in cost for a 100% CO2 capture plant, 15%. For a 30% capture plant, of course, we say this is a reasonable figure of the 5 to 6% is there, and the recovery is the recovery period is about 4 to 6 years. Between 4 to 6 years, the entire cost can be recovered by production of multi-purpose fuels, by production of hydrogen, by production of biodiesel, by production of methane, by injecting into the depleted coal mines. And depleted coal mines have to be used actually. I think this is a very good idea. Just like enhanced oil recovery. If you go to USA, they are mostly having thermal power plants near oil wells, mostly because they use a lot of oil also in the thermal power plants. So they are using it mostly for the enhanced oil recovery. Enhanced oil recovery is the prime motive behind suppliers of carbon capture plants in US. But solar integration is a very, very new concept actually. This has to move forward. And the biggest challenge in the solar integration is today the thermal storage. How to do the thermal storage? Yes, I appreciate Brahm Kumari Ashram at Mount Abu. Yes, I've tested that plant. I was one of the members of the testing team. I've seen that this plant is very good, and the thermal storage has been done. Thermal storage has been done using what is called shells, cast iron shells. The sun focuses into the cast iron shells, and the coils are around the cast iron shell. Just imagine, coils are around the cast iron shell, and sun is focusing into the shell. So producing steam when the sun is there, and producing steam even when sun is not there, because the cast iron has got a heat capacity of the order of 200 kilowatt hour per meter cube. So yes, so that's a good concept. But 15% increase is there, and 5 to 6% is 30% carbon capture plant. But let's go for 30% carbon capture plant initially at one of the 500 megawatt unit and see the results. Then only other power plant will follow it. As far as storage in RGPV CLCSP is concerned, the RGPV CLCSP was the purpose was to demonstrate 600 degrees centigrade, and that has been achieved. And and 30% kilowatt power was produced. 30 kilowatt was the installed capacity of that particular CLCSP plant. And 1 megawatt plant, which was envisaged further as a second stage by Tamura, which DPR is already ready, is for rock storage. Rock as thermal storage, or the pebbles as thermal storage. Remember, the lot of automation is there nowadays. SCADA and data acquisition system is important. We all know, very important. But automatic dual axis tracking and remote monitoring is much more needed. The time has come, there is a remote monitoring is needed, and the time is there when dual axis tracking should be fully automatic with respect to sun. So big receivers are there nowadays, 60 meter square. Ours is 16 meter square reflectors, and are 60 meter square reflectors, big size of reflectors. These are known as Schaeffler units.
I hope participants are not having any questions, sir.
Well, I wish they ask some questions, or
yeah, definitely, sir.
Maybe
I too was thinking, because
maybe Thapar Saab may be having some.
Today's session was purely an interdisciplinary session. There are many.
Thapar Saab may be having some questions, because he has done a lot of analysis also of in the renewable energy sector, particularly in the wind side. But this is other direction. But there may be some questions from Thapar Saab. I'm expecting some questions. Thapar Saab, please. Of anybody from energy side, maybe Savita ji or anybody. Okay. Pankaj Jain, sir.
So we can conclude this session, I hope, then, exactly. Yeah. So I express my sincere thanks and gratitude to Professor A.K. Sethi, sir, for giving such an informative lecture on carbon capturing. And thank you, sir. You have spared a valuable time for us for this session. Hope to listen to you soon for further programs, sir. On behalf of the organizing committee and Department of Electrical Engineering, extend my heartiest. Thank you very much.
Thank you. Thank you very much. Thank you. Okay, sir. Thank you.
Thank you, sir. Thank you very much.
Our next session will start. Ritu, you can, Narayan will brief the participants.
I think I was a little faster. It looks actually I could have covered in 1.5 hours actually. Yes. I hope I could